My name is Arietis Fisher-Burns, and this is my final project for Environmental 220. So for my project, I decided to go out to Morro Bay Estuary, where I live. The estuary itself is 2,300 acres, and Morro Bay sits at just above sea level at 62 feet. It has a Mediterranean climate and a lot of amenities that draw people in, such as bird watching and recreational activities like kayaking and swimming in the estuary and in the ocean. We get to see a lot of migratory birds and some shorebirds, as well as sea otters, sea lions, crabs, clams, and we can even find some small sharks in the water. My objective with this project was to monitor Morro Bay's vulnerable estuary wildlife and resources to deter from further development within the bay and to protect critical avian migratory habitats. Currently, there are 538 acres listed on the southern shore of Morro Bay, as shown on this image here. So I decided to go out to this area to study what kind of birds there were and what kind of landscape might be affected by development. I broke this into 3 tests. The first one was to do an avian species count. All of these are going to occur at high tide and at low tide. For the avian species count, I needed to bring out binoculars, a field guide, pencil and paper, or what I used was my phone to make an Excel sheet to record the species seen, a calculator to figure out the amount of birds that I saw, lots of layers of clothing because weather out here is unpredictable, and a buddy to help me with identification. Another test I did was water turbidity. This was similar to one used for the surface water lab. So water was collected in a 100 milliliter graduated cylinder. There was a Secchi disc printout underneath of it. I put that in a plastic bag to protect it from water, and I used a pipette to fill up the cylinder. The third and final test that I did was soil and water temperature. Now, this was specifically so that I could get a better understanding of some of our aquatic plants' needs, like the eelgrass that is shown here. All that I needed for that was a thermometer and a stopwatch. I was sticking the thermometer in the sand and turning or the water and timing it for a little while until I got the temperature. Conveniently, I live about 15 minutes away, so the 8 hours in between high tide and low tide were not wasted. I did 1 hour long bird counts for that, so I'll talk about the times in just a second. And then I also did the sampling and testing in between. Now, the limitations for this, it does require a permit. I was at a public park, but walking out into the mud, especially during low tide, does require permits for collection. That I do have through my work, so I was good there. But I had to be safe in the mud, so I wore mud boots. And I did have some limitations of identification issues. This is where my buddy came in, but even then, I believe that there was some bias towards less species just because we didn't have all of the answers as to what we were seeing. So collection occurred on February 9th, 2025 from 8:15 in the morning to 9:15, as well as 4 o'clock to 5 o'clock in the afternoon. That is high tide in the morning and low tide in the afternoon. At high tide, we had a 5.05 foot high tide. It was sunny, there were no clouds, and it was 49 degrees outside. There were people walking around with dogs. I think it was about a dozen people and a couple dogs. In the afternoon, our low tide was a negative 0.56 feet. It was a really great low tide, which allowed me to walk much farther out onto the mud to get some samples. But it was cloudy and much windier, although it was warmer at 62 degrees Fahrenheit. The most stark observation from this was how many more birds there were during low tide. There were a similar number of species, but as you can see on the graph, it was over 2.5 times the amount of birds seen during low tide than during high tide. There were also some marine mammals spotted, such as a sea otter, a sea lion, and there was a beached bat ray. Now, the mean, median, and mode were conducted from the avian species. The mean for high was 13.4, while the low mean was 37.1. The median of this is high tide 5 and low tide 4. And the mode gives a little bit more insight into the mean. I think that the median's more reliable of a measure of how many birds we were seeing of each species because we had such large discrepancies. We might have seen only 1 turkey vulture and 67 sanderlings at high tide, which means that our mean would be a little bit more skewed than something like our median. But our mode for the afternoon, which had the higher amount of birds, we saw 255 American coots. There were so many out there. From the water turbidity tests, we gathered that it was 87 NTU. It was pretty cloudy water, just because it's the convergence of salt water and fresh water, and there's mud being kicked up. It was what I expected. The water temp was consistent across high tide and low tide at 12 degrees Celsius. The soil temp changed a little bit, however. I suspect this is because it had more time to sit in the afternoon, gaining heat from the sun. So at high tide, it was 11 degrees Celsius, and low tide, it was 13 degrees Celsius. This is water that was right at the edge of the tide where it was just missing the water. Now, this data is repeatable, but it will differ based on the season and the tide height and the time at which this is conducted. Because Morro Bay is on the Pacific Flyway, we get a wide variety of birds that we see out here. So birds that I saw that, like the sanderlings and like the long-billed curlews, I know that they are migratory and they're going to change in amount. So this may be repeatable, but it is something that would have to be done throughout multiple years to understand the bigger picture, especially during the migratory seasons. That's what's going to change it. We found that there was turbid water, but pretty consistent temperature, and that it was really being used by the plants and animals and people. I did not include the sea otters or the sea lions in the species counts just because I was only focused on the avian. But them and the plants that were appearing during low tide, such as the eelgrass and the sea lettuce, show that there was more than was being counted, that there's greater diversity. The impact of this is that, as I mentioned earlier, this is listed for sale and development could change the landscape. We're hoping that it is only going to be bought for preservation's sake, but it is possible to get permits to build something out there. Things that could change the turbidity, things that could change water temperature or soil temperature. So as I mentioned, there are definitely a greater diversity of things than we were seeing. I would like to have a better idea of what plants were underneath and what fish were being caught by the birds that were flying above, but that wasn't part of this study. Estuaries are really critical for all kinds of marine life. About 80% of marine life in the ocean starts in estuaries, and that's really in the form of plankton. So if we go having things like construction kicking up dirt and dust, that is only going to create more turbid water, blocking out sunlight for plants below, blocking out the sunlight for things like phytoplankton, which again is really critical for those early plants and animals starting. With the sea otter spotted, it showed that we were seeing not only migratory animals, but endangered animals using the space. And if there is any kind of noise or construction occurring, it could scare the animals away. We just don't want that to happen. So we are suggesting that the area is maintained, which it was very clean, that it is protected, and that it is advocated for. Most of the residents, as found through one of the articles online, are not in favor of the land being for sale at all, and only hope that it goes to someone who is going to preserve it, not develop it. Here are all the references I've used up to this point. I have had such a great time in this class. I had such a great time doing this experiment. I learned so much out of it. Thank you.